Okay, we're going to look at something called functions from graphs. Okay, now this involves being able to determine the algebraic function of a graph by looking at it and seeing some details about the roots and where it cuts the y-axis. Now, just to set this in a wee bit of context, let's say we had a parabola that had a root at 2 and a root at 4. Okay, now it might be reasonable at that point to say that that parabola has the function x minus 2 bracket x minus 4. The reason being is because if I check for the roots by making the equation equal to 0, I'll get x minus 2 equals 0 and x minus 4 is equal to 0, and I'll get roots here of 2 and 4, which is exactly what I've got there. However, that's not completely precise to say that that would absolutely be the function, because here's a different curve. It's taller and it's thinner, but it still goes through in 2 and 4, so it could just be as well argued that that one would be the curve that would give you the root 2 and 4, or this one, or it could be argued that there's an infinite amount of curves that go through 2 and 4, and you could make the same argument that that function will produce the root at 2 and 4. So what we need to do then is put a proviso in front of it and say, well, it's got something to do with that, the x minus 2 and the x minus 4 bracket, but we need to put a k in front of it, and it's our job to find that value of k. So that's what we're going to try, starting with an example 1. Okay, example 1. Right, we've got a parabola that goes through -3 and 2 for the roots, and it cuts the y-axis at -12. So again, it would be reasonable at that point to say, right, well, the root of -3 comes from a bracket of x plus 3 and the root of 2 comes from a bracket of x minus 2, so it would be reasonable at that point to say the function must be x plus 3 bracket x minus 2, but as discussed, there's an infinite amount of different curves that could go through -3 and 2. And the same argument could be used for every single one, that would be the function. Instead, what we need to do is put a proviso in front of it, which is k, and find that value of k. Now, we've got a clue in the question. The clue in the question is this point here, which is 0 minus 12. As you can see, it cuts the y-axis at -12, so it must be 0 minus 12. Okay, so what we can clearly see there is that when the x-coordinate is 0, the y-coordinate is -12, so I'm just going to sub that in here. When the y-coordinate is -12, the x-coordinate is 0, so I'm writing down the exact same line again, but where I see y I'm replacing it with -12, and where I see x I'm replacing it with 0. Okay, so 0 plus 3 is 3, 0 minus 2 is -2, so that's 3 times -2 is -6, and times that becomes -6k. So I've now got, bring that down, divide k equals -12 over -6, which is 2, and then that gives me the function. The final answer for the function then is 2 bracket x plus 3 bracket x minus 2. Okay, so how did I do it again? Well, first of all, a root of -3 comes from the bracket x plus 3. A root of 2 comes from the bracket x minus 2. I put my proviso k in front. I've then got an extra point in the question, which is 0 minus 12. When x equals 0, y equals -12, sub that in, that allows me to find k. So -12 equals k bracket 0 plus 3 bracket 0 minus 2. 0 plus 3 is 3, 0 minus 2 is -2. 3 times -2 is -6, -6k equals -12. Bring the -6 down, divide, and that will give me 2, and there's the final answer. Okay, let's try an example 2 then. Example 2, and this time I've got this function. Okay, so I've got a root at -2, I've got a root at 1, and I've got a root at 5. I'll come through the y-axis at 30. Okay, so a root of minus 2 comes from the bracket x plus 2, a root of 1 comes from the bracket x minus 1, and a root of 5 comes from the bracket x minus 5. I'm going to put my proviso k in the front. I've got this point up here, which is the point 0, 30. So when x equals 0, y equals 30, and I can put that in. When y equals 30, x equals 0. Okay, 0 plus 2 is 2, times 0 minus 1 is minus 1, times 0 minus 5 is minus 5. So I've got 2 times minus 1, which is minus 2, times minus 5, which is 10. 30 equals k times 10, that's 10k. Bring the 10 down, divide, k will be equal to 30 over 10, and k is equal to 3. So the final answer then is y equals 3 bracket x plus 2 bracket x minus 1 bracket x minus 5. Okay, let's try another. Okay, I've got a root at 1, a root at 4, a root at 6. I'm going through the point 5, 8. Okay, root 1 comes from x minus 1. A root 4 comes from x minus 4. A root 6 comes from x minus 6. Get the k in the front. There's the clue in the question. When that's my extra point. When x equals 5, y equals 8. When y equals 8, x equals 5. Okay, 5 minus 1 is 4. I'm going to multiply that by 5 minus 4, which is 1, so that's 4 times 1 is 4. And 5 minus 6 is minus 1, so it's 4 times 1, which is 4, times minus 1, which is minus 4k. Bring the 4 down, divide, k will be equal to k divided by minus 4. That's minus 2. Final answer then is y equals minus 2 bracket x minus 1 bracket x minus 4 bracket x minus 6. Okay, let's try an example 4. Okay, this time we've got a function that goes to the origin and then it has another root at 3. I'm told that this point up here is 112. Okay, so a root at 0, well that would just come from x itself, because if you think about, for example, if I had a root at 0, a root at 3 and a root at 5, then that would come from that situation. X is 0, x minus 3 is 0, and x minus 5 is 0. So the root of 0 just comes from x equals 0, so that bit of the function is just x, bracket x minus 3 for the root here. Now one other point to note here is you can see that the curve doesn't pass right through that root. Instead what it does is it hits the x-axis and then it comes back up in that parabolic motion, so that U-shaped motion. Now when that happens, when it doesn't pass right through the root, but instead you get this parabolic motion which we've got with this particular function, as you can see, what you need to do at that point, if and when that happens, you need to square that bracket. Okay, so that's what we're going to do. We've got our proviso k. When x equals 1, y equals 12. When y is equal to 12, x is equal to 1. Okay, so I've got 1 minus 3 is minus 2. Minus 2 squared is 4. 4 times 1 is 4. So that's 12 equals 4k. K equals 12 over 4, and k is equal to 3. Final answer then, y equals 3x bracket x minus 3 squared. Okay, we'll pick them up tomorrow then.